Okay, so practice at 2.5. This part was remaining, right? Second, question number 2. So we'll start with this. So first one, you have to find out the value of x. Okay, you have to find out the value of x. And this is read as mod of 3x minus 5 is equal to 1. Now, these are all equations. There is a mod sign and there are equations. If you see in the previous one, these were not equations. In question number 1, these are not equations. Okay, these are just expressions. Okay, these are just algebraic expressions, while these are equations. Now, when you're working with equations and you firstly is, this has a mod sign here. So the first step will be to remove this mod sign. So whenever you remove the mod sign, so inside the mod, whatever is written inside that sign, whatever is it, 3x minus 5, you write it as it is, equal to, on the other side of the equal to sign, you always put plus minus 1. Okay, this is read as plus or minus 1. Is it clear? Yes or no?
No, sir. Can you explain again?
Yeah. So you see, first, in this equation, we have to find out the value of x. So this equation is read as modulus of or mod of 3x minus 5 is equal to 1. Now, when you're solving it, this such type of equation, the first step will be to remove this mod sign. Okay, these lines that you can see, this mod sign has to be removed. Now, the method is when you remove this mod sign, on the right hand side of the equation, you put plus or minus. This is read as plus or minus, and this 1 as it is. So plus minus 1, plus or minus. Now, in the next step, I'll show you what to do. Now, this is read as plus or minus, means first what you do, 3x minus 5 is equal to 1, that is plus 1, or 3x minus 5 is equal to minus 1. So you see, this plus or minus 1 means like this, plus 1 or minus 1. Now, is it clear?
Yes, sir.
Okay. Now, we get two equations here. First one, second one. Both these equations you solve now. Separately you solve. So first we'll solve this one. Take minus 5 on the other side. What will happen when you take minus 5 on the other side? This will become is equal to 1
5.
plus 5. So 3x is equal to 6. So what is the value of x? X is equal to
6. 3 upon 6.
6 upon 3.
6 upon.
6 upon 3. That is 6 divided by 3, which is 2. Okay, 3 ones are 3 twos are 6. So in this first equation, x is 2. Or now solve this. Take minus 5 on the other side. So when you take minus 5 on the other side, this will become minus 1 plus 5. Correct? So how much is minus 1 plus 5?
4 plus 4.
4. And x will be equal to 4 upon 3. Now this 4 cannot be divided by 3, so we'll leave it as it is. We'll leave it as a fraction. So x is equal to 2, or x is equal to 4 by 3 is the solution. Did you understand this? Okay,
Yes, sir.
go through the sum and then write it down.
Done, sir.
Can you try the second one?
Okay.
Exact same way, same method.
So I got two answers.
Yeah,
X is equal to 6 or x is equal to 1.
1, correct. Show me the calculation. I just want to see. Okay, there is one mistake you have done. You have done a mistake. I'll show you. Look at the screen. So first step was correct. 7 minus 2x is equal to plus minus 5. Then 7 minus 2x is equal to plus 5, or 7 minus 2x is equal to minus 5. Now look at the first equation. Now in the first equation, what are you taking? Which number are you taking on the other side?
7
7. What is the sign of 7? What sign does it have?
minus
Huh? Which minus is for this term. So to check the sign, you see what sign is in front of that number. So what sign does 7 has?
plus.
Plus. So when you take plus 7 on the other side, what should happen?
It should become minus.
Minus 7. And this is minus 2x as it is. 5 here as it is. Plus 7 went on the other side, it became minus 7. Okay. Now minus 2x is equal to, how much is 5 minus 7?
Minus 4
Minus 2. Now if you see both the side, there is minus minus. So what will happen?
plus. Minus
Yes.
into minus plus.
Yes, it both gets cancelled off and it becomes plus. So x is equal to, or if you don't want to do that way, what you can do is, you can take x is equal to minus 2 divided by minus 2. Correct? So here x is equal to, how much is minus 2 divided by minus 2?
1.
1. So x is equal to 1 here. Did you understand this?
Yes, sir.
Now same thing here. My plus 7 went on the other side. So minus 2x is equal to minus 5 minus 7. Correct? So minus 2x is equal to, how much is minus 5 minus 7?
Minus 12.
Minus 12. And x will be equal to minus 12 divided by minus 2. So minus minus 2 went away, it became plus. 2 ones are 2 6 are 12. So x is equal to 6. So the value of x is 1 or 6. Answer what you got is correct, but the method was incorrect. It was wrong. Now, did you get your mistake?
Yes, sir.
Write the sum again. What you wrote, just cancel it and write it again. And also, don't put 2 times equal to signs, okay? Just put once. I have seen you have put equal to sign here like this. So don't put like this, because here already there is an equal to sign. See, look at the screen. See here, already there is an equal to sign here. So don't put it here again. This one is enough here. Okay, write it down.
Done, sir.
Let's do the third one. The technique is the same. So 8 minus x upon 2 is equal to plus or minus 5. Then you do the same thing. 8 minus x upon 2 is equal to plus 5, or 8 minus x upon 2 is equal to minus 5. Now let's solve the separate equation separately. Let's do this. Now here what you do is you do cross multiplication. Okay, so 8 minus x into 1 will be 8 minus x is equal to 2 into 5 is 10. Did you understand this cross multiplication?
Yes,
Yes.
sir.
Okay. Now take this plus 8 on the other side. Okay. What is the sign for 8?
Plus.
Plus. So
Yes.
plus 8 went on the other side, it became
Minus.
minus. So you have 10 minus 8. So minus x is equal to 2. Okay. Now this minus, if you take, no, this minus x can be written as minus 1 into x is equal to 2. Correct? So
Yes, sir.
what will be value of x?
2.
Hmm?
2, sir.
Just 2. But are you forgetting about this minus sign?
Minus 2. Minus.
Minus 2. So you can write it like this. 2 divided by minus 1, because minus 1 you'll take it on the other side. And 2 divided by minus 1 is nothing but minus 2. Clear? Any doubts here?
Yes, sir.
Okay. Now similarly, we'll solve this equation. Again, you do cross multiplication. So 8 minus x into 1 will be 8 minus x is equal to minus 5 into 2 will give you minus 10. Now same thing, take plus 8 on the other side. You will have minus 10 minus 8. So minus x is equal to, how much is minus 10 minus 8?
Minus 18.
Minus 18. Now if you see, you have minus minus on both the sides. Or what we can do, we'll do the same thing. This will write it as minus 1x is equal to minus 18. And this will become x is equal to minus 18 divided by minus 1. Minus and minus became plus. So you have x is equal to plus 18. So x is equal to minus 2 or x is equal to plus 18. Did you understand this?
Yes, sir.
Okay, go through the sum. Can you see the entire sum? Okay, go through the sum and write it down immediately.
Done, sir.
So this sum is similar to the sum that we did now. Can you try this one? Be careful with the signs. Okay. Can you try it? Okay, try it. One hint I'll give you. What you can do is first, once you take off the modulus sign, the mod sign, take this plus 5 on the other side, do the calculation on the other side, and after that do cross multiplication. Understood? Okay, do it.
Uh, I got two answers. X is equal to 4 or X is equal to minus 40.
Minus
40.
40. Okay,
Minus 40 and 4.
minus 40 is correct. 4, I'm a little bit doubtful. Can you show me? Yeah, a little bit closer to the camera. Up, up. That's it. Hold it like that. Minus 1. Okay, for the minus 41, it is correct. Now look at that portion where you have written x upon 4 is equal to 0 upon 1. Look at that. Now when you do cross multiplication, x into 1 is x and 0 into 4 is how much?
0.
0. So what will be the value of x there?
0.
0. Correct it.
Done, sir.
Okay, so that was some of the last exercise. After that, we just have problem set. So let's discuss. We'll discuss problem set. Okay, this activity, if you see, in this first activity, it is written, there are some real numbers written in these circles. So what you have to do is use these numbers and you have to construct any two examples, each of addition, subtraction, multiplication, and division. So select any two real numbers, add it. Select any two real numbers, subtract it. Select any two, multiply, and then divide. So this first activity is, you can do it, I think. Look at the second activity, activity 2. So it starts here. First is root 3. Okay. So it starts here and first is root 3. Root 3 multiplied by 2 will give you 2 root 3. Now from here the arrow goes this side, and with 2 root 3 you have to multiply root 8. So 2 root 3 you have to multiply it with root 8. So you know this will be 2, and then root 3 into root 8 will be root of 24. Okay, root of 24. Now this you have to reduce now. This root 24 that you can see, this you have to reduce it. So after reducing, this can be written as 4 into 6. Correct? 24, I'll write it as 4 into 6. And you separate the root 4 into root of 6. And you know root 4 is 2 and root 6 as it is. So this becomes 4 root 6. And that is why here 4 root 6 is written. Clear? Now from this, the arrow goes
Yes.
downwards, and they have said from 4 root 6, you add 10 root 6. Now this addition you can tell me orally. What will it be? 4 root 6 plus 10 root 6. They are like so.
14 root 6.
14 root 6. So here 14 root 6. Now here you have to divide 14 root 6 by root 3. So 14 root 6 divided by root 3. So 14 if you keep as it is, and you can give a common root for 6 upon 3. How much is 6 divided by 3? 2. So 3 ones are 3 twos are, and this becomes 14 root 2. Correct? So in this blank you will write 14 root 2. Now next is 14 root 2 multiplied by 2. Now this can be done orally. How much is 14 root 2 into 2?
Root 4. 14 root 4.
14 root 4. And what is root 4?
2.
So 14 into 2.
28.
28. So here you will write 28. 28 plus 3?
31.
31 is already there in this box here. 31 into root 5?
31 root 5.
Correct. 31 root 5. These two multiplication is already done. 3 root 5 into 13 root 5. You will get 465. And end 465 divided by 5. Let's do it. 465 divided by 5. 5 ones are 5 8s are 40. And oh, sorry. So 5 9s are 40.
So 93. So 93.
Yes, 93. Correct. 93. So this is the end. Do you understood this activity?
Yes, sir.
Okay. You want to write it down?
Yes, sir. I'll wrap it up.
Or you can write it with pencil in your textbook itself.
Done, sir.
Okay, then after that we have now problem set. Okay, we'll discuss the first one. First one, choose a correct alternative. So first one, which one of the following is an irrational number?
Root 5.
Yes, correct. Because this, if you take the square root, it will be 4 upon 5. So it is rational. This is already rational. And this, if you take the square root, it
14.
becomes 14. So only this remained. So B is the answer. Second one. Which of the following is an irrational number? Now here you need to remember the second definition of irrational number. Do you remember what is the second definition of irrational number? The decimal representation should be,
0.2746.
but it is recurring, no? 246 is recurring. 0.2746 may, on top of 46 there is a bar. That means 46 is recurring. First recollect the definition of rational number. The decimal representation should be
Non-terminating and
non-recurring.
Non-recurring and terminating.
It should be not, both are non-terminating, non-recurring.
Oh.
Both. That's why remember, write this definition somewhere. The decimal representation of an irrational number is non-terminating and non-recurring. Now look at the first one. 0, the decimal representation. This is terminating. So will this be a rational number or irrational? This is rational, so not irrational. Look at the second one. Here it is non-terminating, but it is recurring. Will this be irrational?
No, sir.
No.
It will be rational.
Keep the definition in mind. Non-terminating, non-recurring. Now look at this C1. In this, only 4-6 is recurring. So is this irrational? No. So only option is last one. And clearly you can see it is non-terminating. It is going on and on. Plus there is nothing recurring into it. Clear?
Yes, sir.
Okay. So keep the definition in mind of irrational number. Second definition. Decimal representation should be non-terminating and non-recurring. If you see the third one, decimal expansion of which of the following is non-terminating but recurring? Okay, this you do for homework because you'll have to divide and see. This you will have to divide and see. So do it for homework. If you see the fourth one, every point on the number line represent which of the following? Every point on the number line represent natural numbers, irrational number, rational numbers, or real numbers.
Real numbers.
Real numbers. Also, if you note one thing, that the number line is also called as a real number line. So real numbers. And last one, the number 0.4 recurring. The number 0.4 recurring in P by Q form is this. You'll have to solve.
Sure, it's 9 by 4. 4 upon 9. 4 upon 9.
4 upon 9. How did you get it?
Yeah, sir. 9 4 is 36 and 40 minus 36. When we put 0 on 4 sure, and we put 40 minus 36, it becomes 4. So it would be non-terminating and non-recurring.
Okay. Okay. So from here, oh, Modara, what is root n if n is not a perfect square? This you can tell me. If this is not a perfect square, then what type of number it is called?
Rational.
Rational? What? See, if it is root 3, this is not a perfect square. 3 is not a perfect, but if it is root 9, 9 is a perfect square, so this becomes 3. So this is a rational number. And this is a surd. And surds are usually unmute.
Irrational.
Irrational. So here they have said that if n is not a perfect square, then this root of n will be which of the following?
Irrational.
Irrational. Irrational. So C is the answer. Next is which of the following is not a surd?
3 root 64.
No, don't say 3 roots. Say cube root of 64.
2 root.
Cube root of 64. So this is not a surd. Correct. C is the answer. Now, next, what is the order of the surd? Eighth one. Order means you have to see which root it is, which root. So clearly you can see it is written.
2 roots.
No, there's double root on it. Okay, 1,
5.
3, 4, 5. Yes, 5. Why 5? Can you just tell me?
Cube, outside there is 2, and
Ah,
root 5 there is square.
yes, yes. So here what we do is here a law of indices is used. Now one thing to note, root 5, this can be written as 5 raised to 1 by 2. Okay, root 5 can be written as 5 raised to 1 by 2. Similarly, suppose if it was cube root 5. So cube root 5 means it is 5 raised to 1 by 3. If it is fourth root 5, means fourth root 5 is 5 raised to 1 by 4. Correct? Now,
Yes.
here if you see, now if I write this in the form like this. So firstly, first it is square root. So 5 raised to 1 by 2. And then after that it is cube root. It will be whole raised to 1 by 3. And now by law of indices, base is same, powers are different. So powers will get added. Correct? Okay. So how much is 1 by 2 plus 1 by 3?
1 by 3. 1 by 5. 2.
So the
1 by 3.
answer is D. Okay, next see the ninth one. Which one is the conjugate of this? So as I said, you conjugate, you just, what you do in the conjugate?
So we take the opposite number. So if it's minus, it will become plus.
So which one is the correct option?
So root 3 plus 2 root 5. D.
1 minute. I think there is some mistake in this. Okay, wait 1 second. Before this one, wait 1 minute. Here, I forgot. Law of indices, I forgot here. Base is same. Base is same. So the powers get multiplied. Okay, I'm sorry. Here I did a mistake. Powers will get multiplied. Okay, when the base is same, powers are different. Powers will get multiplied. Okay. So this will change to 5 raised to 1 by 6. Correct? 1 by 6, and this can be rewritten as 6th root of 5. 6th root of 5. So from through this, C is the correct option. C is the correct option. Okay, I just missed the law of indices. So when the base is same, that is this, index or powers get multiplied. So 1 upon 2 into 1 upon 3 will give you 1 upon 6. And that can be written as 6th root of 5, and hence the order is 6. Is it clear? This one?
Yes, sir.
Okay. And we'll do the last one. Conjugate pair. 1 second now.
So it should be 2 root 5 minus root 3, right, sir? In C.
Okay, yes. Well, see, the meaning of conjugate is you have to change the sign of any one term. Usually what we do is, we just change the sign that is in the middle. Okay, but by conjugate, it means you have to change the sign of any one term. Of any one term, and the sign of the other term should be the same. So if you look at option A, sign of 2 root 5 is changed to minus root 5, and sign of root 3 is kept as it is. While in the other one, it is all different everywhere in the other options. So we can say that A is the correct option. Clear now? Is this some clear?
Yes, sir.
Okay. 10th one I want you to do for homework. There is a modulus sign. So you just have to solve the expression inside. And if the answer is positive, you select the positive one. If it is negative, you make it positive. Okay. So will you be able to do the 10th one?
Yes, sir.
Okay. And for homework, I want you to do second, third, fourth, and fifth. Up to 6. Up to 6, I want you to do for homework.
Yes, sir.
And if you finish it fast, if you finish it and you still have time, do the 7th and 8th also.
Okay, sir.
Okay. So we'll stop here. And in the next class, we'll start with the first chapter of geometry. Okay, fine. So see you on Tuesday.
Bye, sir.
Bye.